Hello everyone, welcome to CodeChef. Myself Jwala Chaurasia and today we are going to solve the problem which came into Starters 197. The name of the problem is All Odd Prefix Sums and the problem code is Odd Prefix Sum. The difficulty rating of the problem is Cakewalk and the prerequisite is at all. Let's start with reading the problem statement over here. So guys, problem says you are given an array A of size n. Can the array be rearranged such that all the non-empty prefixes of the array has an odd sum? Formally, does there exist a rearrangement array B of the array A such that B1 plus B2 till B of I is odd for every I which lies from 1 to n? Output yes if it is possible and no otherwise. Input format. The first line of input will contain a single integer t denoting the number of test cases. Each test case consists of multiple lines of input. The first line of each test case contains a single integer n, the size of the array. The second line contains n integer a1, a2 till a of n. Output format for each test case output yes if it is possible to rearrange the array A to make all prefix sum be odd and no otherwise. It is allowed to print each character in either case. Constraint for t lies from 1 to 100, for n lies from 1 to 100, for a of I lies from 1 to 100. So guys, now let's understand the sample test case and the question more precisely over here. So guys, this question is pretty much straightforward to understand. It says that you are given an array A of size n. So you can rearrange that array in an array B such that if you can such that all the prefix sum of the array has an odd sum. Okay, if it is possible to rearrange this array such that all the prefix sum of those array elements is an odd sum, then we will print output as yes. If it is not possible, we will simply print no. Okay, simple. Now let's take the first test case. In the first test case, we have got array 1 and element which is n and element which is a of 5 is 1. So again, it is an odd itself. Okay, so output would be simply yes. Okay, let's take two second test case, which is this array of length 2, which is n, and the elements are 2 and 4. You can't arrange these in any of the way such that the sum would be no, right? Because both are even, and even plus even is always an even, right? So output for this test case is simply no. Let's take one more test case, guys, the last one from here. So this one, where n is 3 and the elements are 2, 1, 2. Can you arrange this array? Yes, we can arrange. Let's say 1, 2, 2. So if we will take the prefix sum, so prefix sum would be what? This will remain 1. So this 2 will become 1 plus 2, previous of it, which is 3. And this will become 3 plus 2, which is 5. Okay. So yeah, can you see all of the elements, all of the prefix sum are odd? Yeah, so output would be simply yes. So it was possible to rearrange this array in an array P or or any of the array such that their prefix sum is an all of the for all of the i's are basically for all of the index are odd. So yeah, it was possible for this test case, right? So output is simply yes. So guys, I think the test cases are pretty much clear. Now let's move toward the simple solution. So guys, this is my simple solution. Let's analyze with what an array with all odd prefix sum must look like. So define P of I, which is equal to A1 plus A2 till A of I to be the ith prefix sum of A. Then P1 must be odd. P1 is equals to A1, which means A1 must be odd. P2 must be odd. P2 is equals to A1 plus A2, and A1 is already odd, right? So for P2 to be odd, A2 must be even. P3 must be odd. A1 plus A2 plus A3, which is equal to P2 plus A3, right? So P2 is already odd, so again A3 must be even, so odd. Basically, an even plus odd is always an odd, right? So in general, for any I greater than 1, we have P of I, which is equals to P of I minus 1 plus A of I. For both P of I and P of I minus 1 to be odd, A of I must be even, right? One of them. So for the test, that test is also, it was 2, 1, 2, right? So one of them was odd, right? So 1, 2, 2 makes an right array, which we wanted, right? So the only possible way all prefix sum can be odd if A1 is odd and then all of A2, A3 up till A of n are even. Thus, if A contains exactly one odd number, a valid rearrangement exists by placing this single odd number at the beginning and everything else afterwards, right? So otherwise, no arrangement can exist. If it is not, right? So this was some sort of a right observation, right, guys? You need a very keen observation to get to the solution. But this is just very simple one. Now let's move toward the simple C++ code for the question. So guys, this is my simple C++ code. I took the input for all the test cases as well as my array elements. I initialize an odd variable equal to 0. I'm running a for loop and checking for odd element into my array. If there is a single odd element present, that is the count is only 1 for that odd element, then I will print yes. In other case, I will simply print no. And as you can see that guys, I have got my C++ code right. Now let's move to the Python code. So guys, this is my simple Python code. I took the input for all the test cases as well as I took the input for elements in my uh and all of the array. Yeah. And I initialize an odd variable equal to 0. I'm running a for loop and counting the number of odd elements into the array. If that count is only one, basically exactly one, then I will print yes. In all the other case, I will simply print no. And as you can see that guys, I have got my Python code right as well as right. So guys, I think the solution, the code and the approach was pretty much clear. Now let's meet in the next video. Thank you so much guys for watching our videos.